And we are recording. And I'm very happy to have Professor Ken Strain back. He's an experimental physicist, a fellow of the Royal Society of Edinburgh and the Institute of Physics, and is the Deputy Director of the Institute for Gravitational Research at the University of Glasgow here in Scotland. He was part of the international collaboration that successfully discovered gravitational waves. And on the side, there is a large interest in nutrition science. Ken's a friend of the show, having been on twice before. So thanks very much for coming on again, Ken.
Thank you very much, Ali. It's a great pleasure, and I'm looking forward to see how this discussion goes.
So, can you talk us through your understanding and thoughts on coronavirus since the first time you heard about it in China until now?
Yeah, so I think, along with many people, I didn't pay it very much attention at first. It seemed to be maybe a repeat of the original SARS that would grow to a certain extent and then disappear again. And also, work-wise, the first part of this year has been very busy, and it's not that it's not always busy, but it seems to have been especially busy. And so I wasn't going looking for information, papers. I noticed a few papers coming out about for example, high in infection rates and maybe quite rapid spread, although it was hard to judge those back in maybe February because they were it was a few weeks latency in collecting data and publishing a paper. And so they weren't necessarily in a clear context. And then probably when I think Italy was the first real signal within Europe, and particularly around the skiing and scene and in Lombardy, that there really had been a new and very rapid spread in the European context. And so I think very quickly I thought, oh right, so this is definitely coming our way, and I was right from the start extremely puzzled by mortality rates, and I didn't think about it very deeply until John Ioannidis' article that's quite I think probably got notorious for I think the first thing he said was we don't have enough information, and I think no one could have argued with that. But then he did set these brackets on, from rates that were mortality rates that were extremely below what people were discussing, based on very limited testing initially in European countries, especially, and rates that were high but still moderate. It was after reading that article that I looked up the details on, a week or two after that, looked up the details on the Diamond Princess, for example, and there are these numbers which have now been very, very well discussed of.
Just for anyone who hasn't heard of that, Diamond Princess was a cruise ship that was off the coast of Japan, which tried to mitigate spread within the crew and passenger population, but did it in a way that was almost like the opposite of what they should have done. They've been heavily criticised for their methods, and the suspicion is that they couldn't have done more to infect more people on the cruise liner.
Yeah, so I think the sort of thing that's discussed is that the food, people were kept in their cabins, pretty much. I think initially they were allowed to walk out on the deck, but meant to stay far apart. But then a bit later on, it was more and more restricted. But their food was delivered by people who were almost certainly infected, or the food had been touched by people who were infected. Maybe because nobody realized at that point that a very large number of people have symptoms that are not at all severe, and probably misidentify, even if they think they've got some cold-like symptoms, they probably didn't realize at that time that it could have been COVID-19, because the descriptions, if you were to look up, government advice that was starting to be published at that time, look out to see whether you've got it. It was, a very bad cough and a substantial fever. And, you know, I think that's actually, I don't know how rare that is, but it seems to be certainly a relatively small minority of people who have symptoms that severe. And so I find it very interesting in the Diamond Princess that the record, after a long period in terms of exponential growth of a virus, you know, where one person infects another, several people, and then, you know, so if you're in a cabin with someone, you're almost certainly going to be exposed if that person gets infected. But I think at the end of the day, it was just around 20% of people who ever tested positive on that. And I find that very puzzling. I don't know enough about virology or coronaviruses in general. I haven't been able to find anything online that's really argued why that should be the observed rate in a period like that. Particularly giving the point that you made about it's almost as if they did everything that could have been done to expose people to the virus. Now, there are a few things. You know, it was at sea, and so there was a lot of salt in the air, and salt in the air reduces viral transmission to some extent. But, you know, I couldn't put a quantity on that. It's just a pointer that all through this conversation we'll come up with uncertain, unknown factors. I think that's a feature of this. It's all happened so fast, and there's been absolutely no preparation for such an event. Whatever people claim, there manifestly hasn't been any serious preparation done, even if boxes have been ticked and reports filed by governments. They haven't actually done anything. The interesting, you know, I think one interesting thing is why the spread seems to have stopped at something like 20%. And then the other useful piece of information is, I mean, it's sad enough, but in that cruise ship of just about 700 people, 7 died of the disease. And I don't know the age, I haven't looked at the ages of all people on the ship or their medical conditions or anything like that. I don't know whether that information is easily available. But there probably were very few children. There probably were not so many young adults on there. It was probably quite a biased population. And if in that situation, 1% is the mortality rate, then which is lower than many published estimates of mortality rate, or even mortality rates that have been used in modelling consequences for health services and the like, it does make you wonder what the real underlying mortality rate in a broader population would be, and I think that's one of the big puzzles at the moment. There seems to be, it's like living in two different worlds. There's one world in which every message you look for and find says the mortality rates, you know, maybe 1 in 1,000, maybe lower in some populations, something in that ballpark, whereas there are people very carefully. Nothing I say in this conversation will be a direct criticism of individual people or even groups of people. And if I end up being critical of a particular government, I don't mean the government of the day, the people that are there today. I mean how they behaved over the last decade or so as different people have come and gone. So I'd be critical of organizations, perhaps, but not of individuals, because I think it's completely unfair for anyone. There is no expert in this. And so while a moment ago I said that the government hadn't prepared by having a strategy, which I think is true, I think it's not nearly as reasonable to say the people who are trying to pick up the pieces now are falling short, because I think they're almost certainly doing their best. And it's just very unfortunate that they don't have a worked out risk management plan that's got all the right check boxes in to do the job. You know, I'm thinking of things like buying masks and having masks in stock and things like that. They seem to have fallen down pretty big holes there. So when I say that there are people who are getting very different results in maybe serological testing, so looking to see whether the population has a penetration of antibodies or so on. And in some places, they're getting results on very small samples of populations. It's never been done in a large sample of population, at least not in Europe. The results range from indications that maybe in early March or mid-March, the infection rate was tiny, much less than 1%, and other results from Lombardy last week and Germany a couple of days before that were suggesting infection. People had been exposed to the virus at the rate of 15 to even 30 to 40 to even 2/3 of the population. Well, that was a very small sample. And so there seems to be this dichotomy between two ways to look at the problem that are coming up with extremely different answers. And, I find myself drawn, just biased towards one of those answers. And I can see why that's not, that if I were, I would never be in a position of authority. It would be a dangerous position to have, because you might underestimate the effect, and maybe it's better to overestimate it based on lack of information than underestimate. But that's a judgment for other people to make, and for us all to pay the consequences of over the next many years.
Yes, I mean, to me, that's the crux of the whole thing at the moment. Is clearly the priority is to save lives, and to some extent in the background, sort of in brackets, there is the slightly colder sounding, quality adjusted life years, which all health services use to decide whether an intervention is right, where you take the number of years life expectancy that someone has and adjust it depending on what conditions they already have. So, someone with dreadful asthma, for example, that isn't shifting, will have a lower number of quality adjusted life years than someone who's completely fit and healthy with the same life expectancy ahead. So, that, taking that calculation, which is obviously complicated, and weighing it against the inevitable negative consequences of your intervention. So either that's just a monetary figure, or it's thinking about, in this lockdown context, things like increased domestic abuse and probable increased suicide rates, the potential for severe economic downturn. And I'm not just talking about poor Jeff Bezos not getting his 200 mansion. I'm talking about painters and decorators, hairdressers, etc., etc., etc. I'm not sure if in the UK that would number hundreds of thousands or millions, who might not have a career for the next 10 years or more. Who knows? So very hard to weigh up, but I think that to me is the crux at the moment. And so it's disturbing, and I think we don't know enough right now to say whose approaches are working the best, because you can take a country like New Zealand, which was extremely aggressive early on, in closing its borders and enforcing a lockdown, and they've only seen one death. And then you have countries like Sweden, where you have, you do have containment measures. I think people are unfair on Sweden in saying that they're being completely irresponsible. They do have social distancing measures in place and are attempting to isolate the most vulnerable and at risk. But it's clearly a more open, risky policy than full lockdown. So, we can't tell at the moment whose strategy is better. Partly because it's difficult to compare between cultures and countries anyway, but we don't actually have enough data yet of people who have died from COVID-19 to know. And I think that data will come first from Sweden and then from places like New Zealand, because even though New Zealand have prevented deaths up to this point, it seems unlikely given how contagious COVID-19 is, that they'll be able to contain it indefinitely. So they'll see waves of infections. It's just about choosing when, or trying to control when you have your waves of infection, right? And
yeah, that's interesting, because one thing we don't know yet, and maybe it's because fortunately these significantly different viruses, I won't use novel because, you know, novelty is a judgment, and the virologists have said it's novel, but you know, it's a coronavirus, and people of our age have had 7, 8, 9, 10, 20, however many coronavirus infections over the years. But these have all been viruses that have adapted to live with humans at just the right level that they can sustain themselves indefinitely. And I don't think the SARS obviously failed as a virus, and we succeeded as humans at stopping it dead. So SARS-CoV-2 is undergoing this fight with us at the moment. I don't want to suggest any will on the point of the virus, but it's just, you know, just functionally what they do. And it's very hard to tell whether, you know, this is just the, I can't remember the number, 8th or 9th, whatever, circulating coronavirus, and that yes, there'll be infections in New Zealand every New Zealand winter, but maybe maybe that's what you expect. And I think if you look at, it'll be interesting. They're only the first hints now of looking at sort of all-cause mortality rates in hospitals, because the rates in some countries have started to drop, or appear to be starting to drop in the last few days. I'm not going to say much about China data, because I really know nothing about how data from China is reported, and I know there's been a lot of controversy about that, and I haven't looked into that. So I'm going to not say very much at all about China or Asia in general, because I haven't studied it enough to know anything worth saying. And so I'm kind of going to be Europe focused, and maybe with a little bit of thinking about the differences between Europe and the US, which I think there maybe are some differences, and whether that's due to differences in the virus or differences in the way people have reacted, or a difference in the environment, who knows. But I think, so in terms of the European countries, within a couple of weeks, it will be possible to see whether typically the peak all-cause mortality is higher than in average years or worst case years. And I think there are hints that it may not be much higher than a bad, or even at all higher than a bad flu year, or maybe even a bad coronavirus year. Because I think I remember reading that in some, I don't remember the country, but in some care home-like situation, the mortality of coronavirus of one of the older types could be as high as 8% over a winter, where the trigger for an underlying cause of death becoming fatal at that time has been the virus. Even though it's one that when we're young and reasonably fit, it passes by in a few hours of your head feeling not quite right and maybe sneezing a little bit or whatever. It can, of course, can be much more serious. And I think that's another dichotomy. There's this big uncertainty about how different or similar this virus will end up being, because I think you can read in a few different places about the mutation rate. And there seems to be two sides to this. There are epidemiologists who are taking DNA samples and just observing that, or just viral samples, and observing that there are mutations happening. And then you've got the proteomics and protein function people who are looking at whether these mutations are functionally important for the virus. And I think when you read the epidemiologists, you see sort of hypotheses at least being raised of maybe the virus, as it's spreading in the US and in East Asia and in Europe, has mutated enough to be distinguishable in terms of its maybe a rate of spread or so on. So I think it could easily be that. So one hypothesis that I saw was that maybe the East Asia version of it's actually not very successful and it will tend to disappear, and that's maybe quite beneficial for New Zealand, because I suspect a lot of the air traffic is with the broader Asia, especially East Asia. Whereas the European version is being accused of being worse, with the US version somewhere in between. Or if there is just one US version, which I think is probably not the case, because I think there's been documented spread from Wuhan to Northwest US and from Europe, as you might expect, to Northeast US more. So those are really interesting questions that will be answered. But I think New Zealand position won't be clear for quite a long time, because probably if the plan there is to keep isolated until a couple of winter seasons have gone through to see what's happening in the long term, then obviously that takes a certain period. You have to see whether if there's a resurgence in Europe in the autumn, for example, dies away in the spring, comes back in the autumn. We won't know whether that's a one-off resurgence or whether that's going to be every year, every 2 years, every 3 years, like the other coronaviruses. That's about all I can. That's about the limit of my knowledge on that matter.
Mm-hmm. And I suppose with the idea that a new established coronavirus season sounds kind of scary potentially, if we think about it in terms of how we're reacting to this just now. But as you say, we don't know how it's going to look. I don't see how extended lockdown can be tenable, in terms of months and months and months and months. I think to me, knowing where that line is between number of deaths happening due to spread of the virus that would be excessive compared to a non-lockdown situation.
Yeah.
And it's so hard to judge where that line is just now. I think it will take at least a few weeks to even have an inkling.
Mm-hmm. So there's I was thinking about this quite a bit yesterday afternoon, and it suddenly occurred to me that there was actually an experiment done, at least in the UK, and if not, much more widely than the UK. I think it may also happen to an extent in Germany. And that is that, certainly in the UK, the government announced or just started discussing some sort of restrictions coming in place nearly 3 weeks before restrictions actually emerged. And I think if you look back at some newspaper headlines quite early on in that period, were definitely pushing in the direction of, the end is nigh, the economy is going to collapse, you won't be able to get food, and people started hoarding. And quite irrationally, I think, in their selection of things to hoard, but hand gel gone, but good old-fashioned soap, which does a better job, piled on the shelves. Anyway, I had this feeling, and I hadn't quantified it, and Tucker Goodrich in a tweet yesterday quite kindly quantified it for me, that there was actually a substantial economic pulse in the couple of weeks before the 23rd of March, when the restrictions became formal, nearly 3 weeks. It grew with a tail, and then shot up into this bulge lasting basically a couple of weeks, and like plus 40% economic activity in that period. I think, I can't remember, without regard to shopping. And in that situation, I could see a couple of possibilities. But in that situation, basically, most of the population went to shops. And those shops are busy most of the time. I didn't go into a couple of shops because I don't like being in incredibly busy shops tripping over people. And so I actually deferred some shopping. But, the shops were crowded, and either there were infected people in those shops or there weren't. Okay, and that's just coming up to just a month ago. And so it's long enough for the disease to spread and for people to die. You could argue about whether the lag times, 3 weeks or 4 weeks, but it's not, for not many people is it 5 or 6 or 7 weeks, it seems. So where's the huge pulse in infections that were caused by this crowding together, the opposite of staying apart, social anti-distancing that we practiced completely irrationally and in a completely mismanaged way, and by which I mean it wasn't managed. Could it have been managed? I don't know, but it seems that it wasn't. So I started looking, and I don't see any substantial effect of that. So certainly, it's within reason that there were maybe 100,000 people infected in the UK in that period. You could argue it up a bit or down a bit. But if you take 100,000 people and they all go shopping at different times in different shops spread over the country, not uniformly, more in London, fewer in Inverness, and so on. So how many people could they have infected? It must be an enormous number, because all the arguments are that this is a very infectious disease, that that speaking is potentially enough to spread it if you say a P or an S or an F, and singing seems to be absolutely catastrophic, from anecdotal reports from several choirs, like in the US, where after some rehearsals, substantial number of people who were at the rehearsals were infected, and with sad consequences in some cases. But I don't see why there shouldn't have been a strong signal. And then so restrictions probably take a week to have any effect at all, and so one wouldn't have expected a sort of a step function from the high level of contact during the week before to a low level of contact immediately afterwards. It would have taken a few days. But if not already, then in the very, very near future, there should be an impressively strong downward trend. And of course, the problem is that will be very difficult to sort out from any natural viral trend. And even though people will claim that the restrictions are having a powerful effect, I think without having a reasonable model and doing a very careful fit, and if you're right, Bayesian priors and your right measure of outcome, then I don't think I would trust any utterance that's made on that topic for a substantial time to come. And especially, it needs to be a model that applies to several countries, not just one.
Yeah, and I think sadly, with Sweden, it's been a very risky gambit. Currently, some predictions are that they'll see, a dreadful, outrageous overwhelm of their capacity to deal with serious cases, you know, kind of envisioning similar to Italy, where there were undoubtedly excess deaths. By that I mean deaths that wouldn't have happened if the uh, virus had been allowed to pass through the population more slowly. Um,
Yeah,
where you know there's people who can't get into hospital beds because there aren't any left.
No, Italy seems to have fallen foul of a very unfortunate set of circumstances, especially in Lombardy area. I mean, whether the very poor air quality at the time of the initial start of the infection is a factor, it's hard to tell. And people observed quite early on this apparent coincidence that I noticed initially people were showing how green credentials of SARS-CoV-2 because it shut down sources of pollution quite effectively. And so I forget the name of the satellite that tracks nitric oxides in the air, and but in Wuhan and Lombardy there was a pronounced fall. But then other people noticed, well, you know, there was a pronounced fall because those levels had been very high at the time when the infection was initially spreading in both areas. And so if you were to take the nitric oxides as a proxy for particulates in the air as well, and as a ex-asthma sufferer, I know how extremely irritant especially hydrocarbon type particulates are to the lungs, and I can imagine that tipping the balance for a lot of people, you know, between a mild and a severe version of the infection or symptoms from the infection, because we don't know the extent to which that played a part, but it was at least coincidence that the air quality does seem to have been quite poor in those particular areas.
New York, similarly, arguably.
That's true. I haven't looked. I decided a few weeks ago that there was an unending list of questions I could look into, and so instead of looking superficially across many of them, I've kind of focused. I remember reading a comment about New York. I mean, I should say that I'll try to make it the case that everything that I mention, I will have looked at least one level below the surface. So I've followed up, and we'll see, I think, in parts of the conversation where it's quite disappointing how shallow some of the considerations have been in other areas. It's amazing how deep people have managed to go in understanding particular parts of the process. And again, it's not criticism because there's not been much time and people have diverted their efforts into different directions. And you know, it's fair enough if they see some indication of a hypothetical or a hypothesis that could be of use and could maybe save lives, then it's quite a good idea to bring that out and publish it, even if you're going to be ridiculed by the more conventional approaches, because I think the bringing up sort of random ideas for consideration is actually quite a powerful way to fight back.
Yeah, you know, I mean, a major part of your career has been analysing complex data and assessing how much we can know from it. Maybe you can give us some like headline takeaways from the COVID-19 data that you've looked at and some of the interesting points, and then we can go in through your analysis a little bit deeper.
Okay, so I wanted to understand the available data. That's the objective of this. I'm not in the business of trying to predict what's going to happen with the virus in next week or the week after. All I wanted to be able to do was look at the data and try to make judgments, partly for selfish motivation, because actually now I think approaching half of the people who've appeared on your podcast, including yourself over the last week or so, have had a nasty viral infection in the last month or so. And in my case, so since I changed diet and so on and so forth 10 years ago, or starting 10 years ago, I haven't had any viral infection that has caused symptoms lasting more than 2 or 3 hours at most, a slightly stuffy head or whatever, but it's so short that it's hard to know whether it's a cold or an allergy or whatever. It goes away. And I've been keeping track of that back until actually into 2009. And then it came to right at the end of February, beginning of March, when I had a very strange set of symptoms, which I checked against all the published symptoms for COVID at the time, and it just didn't match. And so I dismissed it completely at the time. I didn't know what it was. Virus for sure, but it would things like for a day or so, my nose was feeling very strange, and I've got a slightly weak capillary in my nose, and it bled, which is usually a symptom of my immune system behaving strangely. And it happens if I get really, really tired as well, and I sleep and then I wake up in the morning and this little capillary has bled. And a headache that not like anything I've ever had before, not like migraine or anything like that. Just a sort of how to describe it, just a completely uniform headache, not in a place in my head, just as if the whole surface of my brain was irritated. It wasn't terribly severe, but it lasted without break for 48 hours or so. I don't think I had a fever. Unfortunately, my electronic thermometer battery ran out just as I was making the measurements, and I don't trust the numbers I got. They're a bit all over the place. And I didn't get organized enough to get a new battery before this had moved on. And then after about 2 days, I noticed a very strange sensation in my lungs. Initially I described it as a hot feeling, but that's not right. So I'm going to change that to a warm feeling. Now, I don't believe that if you were to breathe in chili powder, you would actually feel anything in your lungs apart from the irritation. But if you can imagine what you might imagine that would be doing, then that's what it felt like. It was just like, and it was very deep in the lungs. It wasn't just it wasn't like an asthmatic thing where it feels right up at the top. At least when I had asthma, that's what it felt like. And it wasn't very pronounced. And I thought, well, that's very odd. And I didn't think any more of it. And then, but a week later, I realized that I was completely exhausted and getting out of breath, going up even steps. And normally, quite often run up hills and things. So that was very unusual. So felt at that point as if I'd had a really nasty flu or virus or something like that without all the normal symptoms beforehand. So, and of course, then a few weeks later, and I won't say any details that might identify someone, but a few weeks later, I found that there had been a connection to someone who might have been in a situation where they would have been exposed and had meantime had some kind of infection. So, there was a plausible route. And then I thought, oh, well, maybe that's what it was. In which case, it's very different from what's being reported on the media and what's appearing in the government advice. No, when I coughed about 7 times or something. I mean, literally symptom coughs over a period of a week. But my lungs are still not right. And I saw a tweet in which Tucker Goodrich, who had a virus about the same time, also said his lungs were feeling not quite right. I think that was yesterday or the day before. So, and then over the intervening time, I've had sort of oscillating periods where for a few days I feel just normal and fine, and then for a few days I feel quite. Well, I was quite worried at one point because it was very reminiscent of, sort of CFS syndrome feelings, and I hoped that I wasn't going down a return to that sort of horror, because I couldn't think straight, and I just felt that I had very high levels. Oh, I didn't mention, but the time that I was getting out of breath, I also had absolutely typical flu type muscle pains, whether it's IL-6 or whatever circulating in the body. But mild exercise would leave me feeling as if I run a marathon, and or at least 20k. And I even did some gardening, and afterwards my whole body was aching after digging up some weeds. So clearly something significant and different had happened. But of course, I had no idea whether it was SARS-CoV-2 at the root of it or not. But the conventional wisdom would have been there's no chance. Just dismiss that idea completely. And people would still say that nobody, if someone at the end of February in the UK got infected, that's so rare that they must have had a contact from abroad and know about it. And I saw that challenge put to someone on Twitter yesterday. So that point of view, yeah, it wasn't. But on the other hand, it would be quite nice to know if it at some point whether it was or not. So that was the sort of motivation for me to take some interest in the data, and also just the hope that, and I'm quite open about this, it's I'm biased in this direction, that the mortality rate is somewhat smaller than the 1% seen in the Diamond Princess, and maybe considerably smaller. And when we look at data later, you'll see my bias in some cases sticking out like a sore thumb. But I'll try to indicate the areas in which I let my bias push me in a particular direction. And the way I present, if you don't have the same bias, it's easy to see the consequences.
Can I just say there that it is amazing that you went for about 10 years with barely feeling the effects of any viral infection, and it's kind of similar to my experience when I changed my diet in 2016 aggressively. That I went from being someone who got every cold and flu going, usually a couple of nasty upper respiratory tract infections every year, sometimes more, where I would be laid out for a week, and to similar to what you've found. I have been ill, I think once or twice, to the point where I kind of had to stop for a day or two. But the rest of the time, it's the same as you. I can't tell whether it's a little bit of mild hay fever or an allergy to something or cold, and it's not like it debilitates me in any way. It's like I feel something ethereal for a few hours of a day. It's great.
Yeah.
And then similar to you, I had this set of symptoms a few weeks ago that were much more pronounced. Fatigue to the point where, I usually sleep for between 7 and 8 hours every night, and I was sleeping for 9 or 10, and then for 2 or 3 during the day as well. I had a headache as well. I also ended up near the end of the worst part of the symptoms with a kind of king mother of migraines. And that's something I used to suffer from quite a lot. And I don't know, but I mean, in the past, I've identified migraines as being very food related and therefore likely gut related. Well, has to be gut related. So, a lot of people talking about the gut symptoms of COVID-19. And again, I'm the same as you. I had no idea whether I had it or not, but curious curious coincidence there, and it would be good to know if I have had it. But maybe that's something else we can talk about around the gut symptoms. And it's something that Emily Dean's evolutionary psychiatrist picked up early on, because she was one of the real early warning people online, saying this is coming, it's going to be potentially a tsunami, we need to sort ourselves out and prepare ourselves as best we can. She was saying one of the main reasons that we want to halt the spread is that for viruses, you just do not know what the legacy effects of it will be. So, okay, you might knock it on its head and feel 90% better, but what are you going to be left with? You're talking about continued lung dysfunction to some extent. I don't feel right yet, and it's been weeks. So definitely an important point.
Yeah, and there are some real horrors of some follow-on effects or consequential effects that have been discussed over the last few weeks and observed, sadly, in hospitals in a few different countries, either because periods of hypoxia have led to brain damage of a particularly nasty kind that manifests a few weeks later, or there was an article written it was in Le Monde, and it was a really nice article. I mean, I'm not very good at reading French, but managed to get through it. And it was a really nicely written, clear article about I can't quite find it just at the moment, but about it wasn't quite clear what the cause was, but maybe it was because of cytokines, so chemical inflammatory messengers, which can get through the blood-brain barrier and get into your brain and cause chaos in the immune system in your brain, and was causing quite horrible damage to particular places in the brain, and leading to paralysis or semi-paralysis and Guillain-Barré-like symptoms, which are when your body seems to have a growing paralyzation, if that's the word. Become paralyzed from usually extremities up, and it can stop or continue until you're completely paralyzed for a period, and so on. So there's been quite a lot of really horrible consequences that are, definitely known to be caused by the action of the virus. So it does seem that I don't know how that compares to other types of virus that we get exposed to, how common these kind of things are. But certainly, it's an article that I would advise most people not to read. But I was very impressed by the quality of the article. It was kind of pretty close to a scientific, at least an introductory scientific thing, but published in Le Monde, which was interesting.
Yeah, I've read reports of almost dementia-like symptoms in young sufferers of COVID-19 who you wouldn't expect to be dementia afflicted. Real confusion and distress.
Anyway, to get back to your question about the modelling, so you now know the motivation.
Yes.
So I thought, well, what some assumptions can be made that are pretty safe? I looked at so this is, the source is the Worldometer type data. I also looked at the Robert Koch Institute in Germany and the John Hopkins data, but I think the Worldometer data were comprehensive. And cases, it took me embarrassingly more than a few minutes to spot that the cases are just how many tests they've done, times some factor, and that factor is time dependent. And so you can't look at the case data and learn anything without a whole bucket load of assumptions that are different for each country and vary from day to day, week to week, more at the weekends, fewer at the weekends, whatever. So that's hopeless. The other data available are the mortalities, okay, so those are kind of uniform from country to country, but not exactly. But I'm happy to look for factor of 2 type accuracy. This is all going to be done logarithmically because there's going to be a few cases at the beginning of an infection and millions, by the end, and so it has to be viewed in a sort of a logarithmic. How many powers of 10 we're talking about? How many doublings we're talking about? And so factors of 2 end up as being subtle effects, even if not for the people involved. And so I thought it'd be useful. So basically, I assumed that maybe without good reason, but that within every country, the mortality rate would just be a constant, not a certain factor that applies throughout the country and not changing with time. Now, you can pick holes in that because, of course, the sun's coming out now, and that might make a difference, and so the mortality rate might drop at this time. So the number of cases might increase, and the number of deaths might not at this time of year. But basically, I've been looking between February and early April. So I'm neglecting that effect. Okay, it's usually about now that you start getting big changes in seasonal viruses. So that's kind of the one point of view. I also thought that when the population infected is very small, that it must be pure exponential growth. So one person infects 5 infect 25, 25, 125. And that you can't do that for very many cycles before the whole country's infected. But I thought, at least initially, that each country should have a constant R, so-called R value, and that in considering infections, I assumed that people were not infectious for a few days, say 6 days. It's a number I ended up with based on reading some CDC information.
Could you quickly just describe more what the R value is?
Okay, so the R value is that I illustrated one person infects 5, they all 5 of them infect 5, so that's 25, etc. If the R value was lower, the one person might infect 2, and those 2 affect 4, the 4, 8. And if you think of that, the difference in just a couple of cycles of that, so that, say that period I described was one gets infected and then 6 days later infects 5, then you've got 5 that start infecting people 6 days later, and so after 12 days you've got 25 people infected. That's a really, really rapid spread, right? Whereas an R value of 1 or between 1 and 2 would be one person infects it, a week later you've got 2 people infected, a week later you've got 4. That's a really pretty slow rate. Now, flus and other common repeating viruses tend to spread at a relatively low rate. Each person only infects a couple of others, whereas measles is 12. So measles, if you've got a room full of people and one of them has measles, then the chances are they'll be infecting. If people aren't vaccinated, in the old days when people weren't vaccinated, it spreads extremely quickly. So I think the surprising evidence is that the R value, I think if I remember right, from the early days in China, people were talking about R values of 3, which is already quite high, but not extremely. And then a CDC article that I read actually just a couple of days ago said that the serial interval, so the time at which you manage to infect the next generation of people, is 6 to 9 days, and the median R value is 5.7. So everyone's infecting about nearly 6 other people, which is a really very fast rate of growth. And so even quite a small change in the R value, because it's an exponential function, it shoots away up, 555, etc. So from that I'd actually settled on values of about 5, 6, 7 days for the time it took to spread the disease to the next person, and our value roundabout, like 5.4 was the number I would have picked based on eyeballing some data. And you can't really, those things are coupled. If you just look at an exponential curve, you don't know whether a generation is long but the R value is big, or a generation short and the R value is small. Okay, so they do couple together somewhat. And I'm not trying to be terribly formal about this, because I don't really believe that it's an exact constant in every circumstance. I think, for example, you could say that people in the US typically live a bit further apart, people in Lombardy, and so you might expect the R value to be a bit lower and the time it takes to infect someone to be a bit lower. But that's not necessarily the case in New York, even if it's the case in Texas, for example. And then the other assumption I made, and this one's difficult, but just to have some way of estimating the number of cases from the number of deaths, you need to know roughly the length of the course of the disease. And I looked up a few different references for this. You have to have an average. And so it looked as if people who are recovering with a mild infection, it's quite a short course, a couple of weeks from infection to not being infectious again. People who are admitted to hospital, maybe more like 3 weeks and even a bit longer, depending how long they survive. People can be on a ventilator for even a week or whatever. So it's hard to say, and I didn't think terribly hard at putting a number on that, but I made the assumption that basically it was a 3-week course, just to get started on some kind of average. I then thought, well, which country should I look at? So I looked through odometer data for a lot of different countries and thought, well, it's no good it may be interesting to study a country that has very few deaths, but then the statistics are going to be so poor that it's not worth doing. Likewise, as I've already mentioned, China, I don't really know what the meaning of the data of China is. And the UK data are quite noisy. And so I thought, well, let's not use the UK as a basis for this. Let's pick a country that's more advanced than the UK in terms of the progress of the disease. Likely, there are indications that there are more people have been exposed to it. And then sort of compare that, use that as a comparator for other countries. And Italy was the most obvious choice for that, because it looks like it's over the hill, and the daily death rates continuously and steadily falling. And so, it's got all the different phases showing, well, of the ones we've seen so far, showing in the data. So what I wanted to do was to look at the death rate and infer what the case rate would have been effectively 3 weeks before, so that you can tell how many people would be infected and then they would go on to unfortunately die 3 weeks later. The other reason I thought the Italy data were good was that they're very smooth. It doesn't look as like there's been a lot of reclassification of death certificates or anything like that going on, or at least if it's been done in a way that averages out very well. Whereas the UK, we look at it, we'll see that there's a weekly cycle. Every weekend, there's a very low death rate followed by a catch-up. And so, given that 7 days is not a short period in the course of what's happening, there could be a deviation that's masked by the weekly effect. So that was kind of my starting point. And the other things I was keeping in mind were this question of what fraction of the population has been exposed, and I mentioned the numbers earlier, but you could argue that substantially more than 10 million people in Italy have been exposed. I mean, it's assuming it could be a really large number in Lombardy and a bit less throughout the rest of the country, much less in the south. And so be interesting to look to see whether the process of inferring the case number or predicting something in the right ballpark to fit that. And then, even though there's no data to indicate a similar situation in the UK, my first approach in making every decision is, well, if I don't know better, just assume it's the same as something else. So to first order, the UK and Italy are very different, right? Up until up until quite late into March anyway, when there wasn't a huge difference, apart from a slight time lag in the UK about what people had been doing. There was a bigger spread and then restrictions imposed at different times. But given that Italy was probably a couple of weeks ahead of the UK in terms of the course of the disease, but not really, and given that we're not even 3 weeks, or just over 3 weeks into the restrictions in the UK, so we're not expecting any of those effects to have very pronounced, any of those moves to have very pronounced effect up till now. And so at first I was only going to compare Italy and the UK to see if anything could be learned about that. And then in part because, well, I've got friends and colleagues in Germany, and I thought it would be interesting to look to see what's happening there. And it's obviously different. There are things that are similar, because Germany's a European country, so that's similar. But there are also things that are different, namely that they're not getting not getting as many deaths as in the UK, for example, for a population that's slightly larger than in the UK. And I then added Sweden because of the interest that you've expressed a few times in using Sweden as a comparator for the effect of restrictions. But I hadn't been going to do that, but I was very glad I did in the end. And when we look at the data, we can I think it will be of some interest, even not any of the modelling I do, just looking at the data in a particular way, I think might be informative. And I also, I wasn't going to add in the USA, but obviously it's a big place. It's a big, best part of the continent. And so partly intrigued by comments that that people had made about the spread being quite different in the US. I did the data for those in as well. So those are the countries that I decided to look at. So I mean, there's some other just general comments. Countries have their own reporting standards, so we can't really closely compare two countries. But again, factors of two. The mortality I'm pretty sure in the UK, and I suspect in at least some of the other countries, is not very close to the number that's reported. And I don't know whether the numbers reported are big or small, because in the UK, I believe that many deaths in care homes are not counted because they're certified in a sort of quasi-medical situation in the care home. So a doctor goes in and certifies it. But I think the standard is the standard of recording of death certificates is in those circumstances is not thought, has not been thought to be of high enough quality to include in the official statistics, as far as I understand. And I now understand that it's no longer required in Scotland, at least, to do post-mortem investigations of someone as well. So that may affect the quality and the data coming out. So that could mean that the numbers are maybe substantially underestimated. But the other thing is that most countries are doing, to some extent, reporting of people dying with COVID who may have been already quite seriously ill with a comorbidity, and that it, in that circumstance, it's not terribly informative to have recorded it as a COVID death, because it just was a thing that pushed the person over the edge, unfortunately. But anyway, I ignored both of those effects and just said we've got what we've got. We've got data, and I'm not going to try and look to in too much detail. Another of the motivations for doing this was I saw Tucker Goodrich doing his data analysis, and I was intrigued by a couple of the features that he'd pulled out, and I wanted to look at slightly different ways. In particular, because it was clear that in Italy, when he looked at Italy, the early data were quite noisy, and I wanted to understand whether that was something real that was going on with the early spread, or whether it was just whether there could be any information. So, for example, it seems unlikely that a country, doesn't matter which one, got infected because one person flew from somewhere else, landed in that country, and infected the whole country. Okay? It seems about equally unlikely that 1,000 people all came pre-infected and infected the country 1,000 times within a short period, unless it's maybe the US. But for smaller countries, that seems unlikely. And so I think you would guess that the disease in each country actually starts a generation or so before it, 6 or 12 days before it, with a smaller number of people in other countries who then transfer themselves to the country of interest and seed the disease. And how many of them seed with growth, and how many of them seed and then it dies out because they don't socialize in a particular way or whatever. Who knows? But I wondered whether there might be any sort of signature of that in the early data, but really there isn't, because just statistically it's so noisy that you can't really see whether, if one person dies a day earlier or a day later, it makes the curve look quite different. So that didn't really go anywhere, except perhaps in the US, which I think does look different. I mentioned the weekly dips and bulges in the UK, which became clear quite early on and seemed to be repeating. And the other sort of common observation, and I actually sent out to my very small number of followers on Twitter a question to see if anyone could give me a clue, which is what level would you expect that a virus introduced into a population, a virus that could spread, as much rapidly, when would it start to stop spreading? Naively, you might think, well, it's pretty much, you hear this herd immunity rate, and it's usually quoted at 60-70%, right? And I haven't looked into that, the justification for that. But, 60-70% of the UK is a lot of people, 40-something million people, and I can't convince myself that nearly that many people, not nearly that many people have been infected. No matter how much my bias tries to push the numbers up, I can't make it that high. And yet the curves are all turning over. In fact, they're turning over profoundly in Italy, for example. And so I asked that question without getting a response, but that's fine. And I don't think there's an easy answer to it. But it does make me wonder whether there's actually a subpopulation that's infectable, and a substantial part of the population that won't be infected, perhaps because they have just enough immunity from earlier coronaviruses. And you would have expected maybe 2/3 of the population to have had a coronavirus in the last few years, and maybe those of them who are just robust enough, have a good immune system, very much like George Harrison was talking about, people who can mount a good... George Henderson, sorry, seroconversion. I must have been thinking about the wrong group or something. Different. The people produce a lot of antibodies, and that maybe gives them a head start, and so they don't get infected. I don't really know, but going back to the Diamond Princess again, why did only 20% of people seem to be infected there? And maybe that's a number that does apply in larger circumstances, although I fully take on board the very wise statements that Ntaro Iwata made on your podcast when he said you couldn't extrapolate from one situation to the other. And I completely agree with that. But I think you can take clues from one hypotheses generated in one situation and consider them in the other, and maybe that's a not unreasonable thing to do. So so basically, before we look at the details, what I found was that in large measure the UK and Italy were not terribly different, apart from the later onset in the UK, and that so the variables, the real variable in my consideration of the data, I hesitate to call it a model, then sort of an analysis of the data, is the number of cases that lead to one mortality. And I settled on a number around 1 in 500, 1 in 600 for Italy and the UK, and maybe that's wrong by a factor of 2 in either direction, but I find it very hard to get convincing results for Italy if that rate was, say, 1%, as it had been in the Diamond Princess. And as I mentioned before, you wouldn't expect a whole country to be the same as a cruise ship. So you might have expected a fraction of a percent, and I'm using a smaller fraction of a percent, but not by much, maybe by a factor of 2. And if you apply that same number to the UK, then the results don't look completely crazy. If the UK death numbers are really double because of care homes, etc., then I would be forced to use a higher mortality rate. So it's the mortality rate for hospital deaths that I'm talking about. And I don't know enough about Italy to know whether that's those data are exactly comparable or not. And an interesting thing that came out of that is really when the start. Well, I do see quite nicely exponential behavior early on, and you can kind of infer when the startup date was from that. So that was kind of the first step. And then the second step was really adding in the other 3 countries, Germany, Sweden, and the US, and seeing what lessons could be learned from them. So that was a kind of overview of the modeling. Don't you want to look at a couple of the
Absolutely, yes. So
the results?
I
shall share my screen.
If you share your screen, then we can have a look at the graphs. I've been saying to people that obviously this whole situation is dreadful and completely undesirable, but I've been kind of being able to look at graphs all day, which is something that I enjoy doing. I'm not trying to be glib or anything. It's obviously a tiny silver lining, but for me personally, but and I hope that the data shows that that it's going in a more optimistic direction. But it has been fascinating to look at the data coming out, because this is kind of a once every 50 or 100 year kind of occurrence.
Okay, so I'll try to describe as much as possible for people who wouldn't be seeing the graph. So can you see the first graph there?
Yep.
Yeah, excellent. So the graphs are all essentially, and along the horizontal axis is days, and I've called day 0 as the 1st of February, or day 1 as the 1st of February. And so we've got 72 days updated yesterday. So there's 72 days of data. So the whole of February, the whole of March, and just under half of April. And the graphs are all logarithms of numbers of either mortality or infected cases, or the model that goes along with that. And so I've got just by typing in the worldometer death rate from Italy, I've got a curve that starts on February the 21st, with the first death, and has been coming up for 20,000, around 20,000 by now, and the curve kind of relatively smoothly progresses up, curves over from about just into the end of first week of March. So it rises pretty steeply until the first week of March or so, and then it rounds off.
For those looking at this who aren't familiar with logarithms, you've got that handy scale on the side. So between 4 and 5 on the vertical axis, you go from 10,000 to 100,000, so 10, 20, 30, 40, 50, and so on. And then between the 3 and 4 underneath, and it goes from 1,000 to 10,000, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for those just listening, let's keep in mind that they'll need some description of what's going on.
Yeah. So the Italian death curve starts in excuse me, starts 21st of February, rises up pretty steeply, 10, 100, 1,000 deaths into the first week of March, but then it's that increases from 1,000 to 10,000 in about a fortnight, and then the next fortnight, the last fortnight, it increases from 10,000 to 20,000. So that's a really far from a straight line. So exponential growth, you would expect a straight line on this plot, and it's only a straight line until about the first 1,000 deaths, which is a relief because it would have been much worse had that trend continued much longer. So that intrigued me because I thought, well, what's stopping it at a 1,000 deaths? If there had been, say, a 1% mortality rate, then 1,000 deaths would have inferred, 2 or 3 weeks before that there would be 10,000 cases starting, 100 times the number of deaths. Why would the rate of growth of the disease start no longer expanding at the same rate when there's 100,000 people infected? The pink plot here is the UK death rate, which started just in the early days in March and climbed up. Very similar gradient, very similar slope up for the first several hundred deaths, and then you could see these weekly ripples in it. So the curves wobble slightly up and down with every 7 days as I think the accounting for deaths at the weekend is added in on later days, or an effect that's like that. It comes up to just a bit more than the 11,000 that it was a day or so ago. But it's obviously the main thing is that the early stages, it's a good more than 2 weeks lagging behind Italy. So as I mentioned earlier, for each of those curves, which are just the numbers out of the data sets without any processing by me at all, I took for both countries, I took 660 times or 500 to 660, I tried a few values, times the death rate, and plotted it earlier time by basically 3 weeks minus the 6 days. So what I wanted to do is plot the number of cases at the point at which people were becoming infectious, okay? A case that could then infect. So that the blue and red curves up here, which are for Italy, the upper one, and for the UK, are just exactly the lower curves shifted up. And because this is a log graph, it's just addition. The factor of 660 is just an addition. But I've plotted them back by just over 2 weeks in time. And you could argue, so for example, you should say, no, the course of the disease is to death is longer. So these curves should be moved a bit to the left. But even a week doesn't really make any substantial difference to how you would interpret this graph. Or you can say, oh no, the death rate should double, so these curves should then be brought down a factor of 2. A factor of 2 is only just under a third of a decade, so it's only a third of one of these grid line spacings on the graph. So again, it doesn't really make that much difference to how the graph looks. So does that deal with that plot, do you think?
Yeah, I think so.
Okay, so I then take the two case curves. So the graph's the same, it's exactly the same layout, same axes, everything, same numbers, 1 to 100 million. And I made a very simple model. I didn't think this would work very well. I was surprised that it actually fit. And so what we've got the curve for Italy, the blue one, and the blue one, and the black line's the model, and then the curve for the UK is the red one, and these are the number of infectious cases at different times, starting from in Italy early February up till a couple of weeks ago or so, and in the UK starting in mid-February, just after mid-February, and coming up to a few weeks ago. So then I thought, well, the simplest thing you could do is to model the initial part of the curve with an exponential, so the exponential growth that I described earlier. And the interesting thing is the same model, the same gradient fits the two curves as well, as you can see there. To me, remembering that the start of the data curve would be expected to be noisy, because even though there are thousands of cases, it's only 1 or 2 or 3 deaths, and if they happened a day earlier or a day later, the curve would look quite a different shape. So I know Tucker saw some very early, extremely steep spike on in Italy, and I'm not sure whether that's real or not. That was one of the questions I wanted to answer, but I haven't really been able to. And so what we've got here is for Italy, we've got the blue curve of cases, and pretty much perfectly, I would say, apart from right at the very beginning, tracking that up till nearly 1 million cases, infectious cases, is the exponential growth. And then once you get up to about 1 million, the curve flattens dramatically. And the start of flattening is before the end of February. And the implied start of the disease, if there were, say, 10 people who infected Italy, was before the middle of January, which is interesting. And as I mentioned, if you don't agree with the assumptions I made, it's making a difference of a few days to those numbers, not weeks. The UK has the same gradient. The data are noisier, so you can see that the curve kind of oscillates around my simple straight line exponential model. But I still think it's, given the weekend effect, is a reasonable fit. Interestingly, the deviation from exponential occurs, in the high 100,000s of cases, or certainly a bit below 1 million, and then it flattens off. But it flattens off in a way that's not as pronounced as Italy. And so at the moment, it looks as if the UK cases are on an upward trend that may exceed the Italian cases in this model. But again, remember, these estimates shouldn't be taken seriously to factors of 2. And so, don't compare. Those who can see the curves, don't compare them in too much detail. What else is there to say about this? So the implication would be that the number of cases in Italy is settling out at something in the region of 15 million cases. That's probably still a controversial number, but I couldn't see any good justification for pushing the rate down very much. You could maybe push it down a factor of 2, but that would still give 8 million cases.
Which would be about 25% of their population. I think they're about 60 million.
Yeah, okay, okay. Yeah, okay, that's fair enough. And, you know, you could argue that it's not that you have to. Another reason I don't want to be too precise about this is, you know, there may be 5 million, no, 5, 6 million people in Lombardy have been exposed, and out of 10, and there might only be, you know, a few percent in some rural areas far away in Italy. Because I remember even looking at between Lombardy and Veneto, which is pretty much adjacent or adjacent, the numbers were radically different, of course, of the disease. So I didn't want to get into looking at anything smaller than a country of, you know, several tens of millions of people, because the data are just not convincing. And
Yeah, that makes sense. And I wonder if it's worth just mentioning. This is one of Dr. Goodrich's main points: is that he thought that a lockdown couldn't explain this falling away from the exponential growth because the timings don't add up. Now, in my mind, you know, like Professor Iwata said, the lockdown is just, you know, one part of a spectrum of social distancing measures,
yeah,
and informal social distancing measures may have come into being in Italy before the lockdown just because people were afraid, and it's not clear at what point and to what extent that could have happened. But you can see clearly the deviation from the straight line at around the, what's that, 25th of March, 25th of February.
that's about right. 25th, 26th of February, something like that. So it's quite sharp. It's quite surprisingly sharp deviation.
Yeah. And so what was 2 weeks before that?
No, remember, this is already timed back. This is the point at which the person is infectious.
Got it. Yes.
So that is the date at which they would have had to have been a lockdown, if that's the explanation for the change in the curve.
Yes, and
because when
was the lockdown in place in Italy?
I don't know. I don't remember.
And thinking about this sort of potential informal lockdown, I'm just going to look that up just now because
yeah.
So yeah, on you go.
Yeah. So while you're looking that up, I'll just say that I mean the UK, the turnover is equivalent turnover. It's not quite so clear cut, but it might be around the 10th, 12th of March. Now, I would say that is the peak of pre-restriction economic activity, which Tucker Goodrich kindly looked up for me on Twitter yesterday. So I had this feeling that the UK behaved collectively with the most bizarre irrationality if people were worried about a virus. The government didn't do things that could damp down what I'm about to say. The press made sure that they jolly well ramped it up to the maximum they could, and people suddenly got very scared that in a week's or two's time there wasn't going to be anything in the shops. And what did everyone do? They went into the shops. They crowded into the shops. In fact, they crowded into the shops so much that I avoided going into some shops because they were so busy.
And what was that date?
That was about the middle. That was about just the date where this downturn starts here. The UK restrictions came in officially on the 23rd. And so we're talking about a broad period of a week or so before, week to 2 weeks before that. It was an initial slow upward trend and then a bulge just around the middle of.
Before we go further into that inflection,
yeah.
The Italy lockdown started on the 9th of March.
Yeah, so let's look at the curve. So our curve here folds over on the 26th of February, by the 26th of February. And remember that if people argue against my modeling, they probably would say that, I used the word modeling, my crude analysis of the data, they probably would say that my blue line here, the Italy curve, was too high up, not too low down. And if you bring it down, and they probably would say it's too far to the right rather than too far to the left. So, because the course of the disease is longer. So I don't think you can really push that date around very much. You can't get it to the 9th of March. And at the 9th of March, there could be a tiny inflection there. I mean, I think there's a gradient there and then a turnover. Just actually a couple of days before the 9th of March. But then at the actual 9th of March, there's nothing. There's just absolutely nothing.
And you wonder then if you've got about 2 weeks lag or 2 weeks, the inflection starts 2 weeks ahead of the lockdown. Could there be some, informal social distancing effect starting to take place where people are being more cautious in some respects, or do you think that's implausible?
No, I think it could be, but I think that would be a 10%-ish effect. I think these curves would allow something like that at the 10% effect. And, that hardly shows up. And 10%, third of a day in terms of the virus. On the exponential curve, this curve's 34% a day increase in the virus. That's a scary, scary, scary number. That's an R value about the same as the CDC numbers were, and I was quite happy to have settled on this number before I read the CDC article. I played around after reading the CDC article to see if there was if I should push numbers up or down, and I did change the lag time to 6 days rather than 5, but other than that, it hasn't really changed. But yeah, I don't see any evidence. And in the UK curve, I just don't see any evidence for this bulge. And I don't see how to get out of the conclusion that while there might have been of order 100,000 people going around the UK, going into supermarkets and being infectious at the time, there's no sign that anyone got infected from them. So either there weren't 100,000 people, but that pushes the mortality rate up enormously. And it also really begs the question as to why the curve rolls over at the point when there was absolutely no sense of restriction, as I remember it, in the UK. In fact, as I said, completely opposite, as Tucker Goodrich found there was a substantial increase in economic output.
And almost even
in that period.
I think the weather was nice, so people were, I think, irresponsibly almost going out for one last hurrah.
Yes, yeah. So I find that quite perplexing, because I'm not convinced that restrictions are merited. Well, I don't need to be. I'm not in a position to choose. I'm fairly convinced that the benefits and harms have not been evaluated and will probably be found to be more on the harm side than seemed reasonable than I imagine was in the minds of the people who made the decision at the time. But who knows? That'll require inquiries in years to come.
And this echoes what Professor Awata was saying, which is that lockdown at the extreme end of social distancing measures is really known to be only particularly effective when it's done before you get this explosion of cases.
Yeah, I mean, you can see, like New Zealand, as George was saying, and other places where they really got on top of it. So I think the only thing I haven't said about this is the inferred start date. If there were, say, 10 people who came into the UK and were infectious, it was the 1st of February.
Yeah, so you go down that line there, assuming a constant growth of infection, and you find that when you get to patient 0 in the UK.
Yeah, so, and I assume that it wasn't just one, that it was a handful or 10 or something. People came in roughly at the same time. And interestingly, I think that would fit some other anecdotal evidence about people being infected that I have. Right, and then I thought, well, okay, let's compare Germany, Sweden, and the USA. So we've now got a whole family of curves. These are just the raw data from the worldometer, and left Italy, which is the earliest start and until the USA just recently took over the biggest mortality. Well, I won't talk about the USA. Then we've got the UK that we've talked about before, which is lower, but trending more steeply towards the Italian numbers. And then we've got Germany. I mean, in the log curve, they look all rather close together, but I think, so in Germany, the timing seems to be just days behind the UK. Or you could say that the timing's the same, but the numbers are smaller by a factor of about 3, half of a log, major log division here. So it's about 3 times lower. So if the UK and Germany started at the same time with the infection, and I think there's actually evidence from the viral mutation thing that Germany may have been slightly earlier, if anything, than the UK, or at least the Northwest Europe region, mainland Europe region, maybe started a bit earlier. And the rise is actually, not that different from the UK. So from factor of 3 below in the early stages, at the latest dates, Germany is a factor of 4 below below the UK.
So it's just rolled up slightly sooner there.
Yeah, so it's just a little bit different curve. And then the one that really surprised me was Sweden, because everyone's been talking about the disaster that is Sweden. And I hadn't really paid much attention apart from seeing the occasional tweet fly by and following a couple of them up. I hadn't looked into it. And it's very interesting that, so the curve that we see for Sweden for the mortality is the same shape to all intents and purposes as the German curve, but just another factor of 3 or 4 lower. It may be that at the beginning there's a slightly steeper trend, but the numbers are so small that I wouldn't worry about that. But the two curves just go parallel, or at least Sweden is not progressing in a way that's worse than Germany from either lower or later starting point. And I think for Sweden, I'm willing to believe it's a later starting point. Okay, I'm less willing to believe that for Germany. And I think that there's good evidence of differences in medical care in Germany that may make a substantial difference to the mortality rate. Apparently, they have essentially the best ventilator per patient ratio in the world, and things like that. So I'm inclined to believe that Germany has a low rate compared to the UK of mortality.
So we're really at this point in Sweden that
it's
tantalizing, because you want 2 more weeks on that at least before you can start to say that really is rolling off.
Sure.
Because you look at somewhere like the US curve, where it's really there's some serious confounders in there that make it quite bizarre in shape. But at the moment, promisingly, Sweden looks like it's rolling off.
Yeah, and it looks like it's paralleling Germany. That's I think that's the best way to say it, that there's nothing conspicuously different between Sweden and Germany, apart from Sweden's 4 or 5 days behind on the curve, which is interesting. So I kind of skipped over the US curve, and I don't really understand it, what's going on. I suspect that it's because it's such a huge country, and it was probably seeded separate, different infections, versions of the virus, maybe even functionally different versions of the virus that have different spread.
Not to mention the fact that different states can almost be thought of as different cultures, and they can be quite separate in a cultural interaction and rates of movement internationally and all the rest of it.
Yeah. So the graph, unlike the others, which have all been fairly smooth inclines, without strong features until they roll off, so a straight line, then a roll off, essentially. The US has this 0 to 10 patients in 1 or 2 days, and then a rather low exponential gradient for a couple of weeks. Not the same curve as all the other countries have the same initial gradient. But the US has this curve that instead of launching and then turning over, actually launches and then has this strange sort of concave up curve section. So it always seems to be underneath the curve and then steepening and steepening. And then after, in the last 10 days or so, the steepening rolls off. So it's a much more complicated curve. And I'm not going to try to explain much of that. I'm just going to blame it on exactly the points that you made, that it's a different country and I don't understand it, which is fine. So my comment is the USA curve is unlike the others. And I'm going to not say too much more about it. So just as a reminder, the Germany and Sweden data suggest they are either or both of a much lower mortality than the UK and Italy, or a much later start. Okay, and so I bore those points in mind when doing models for them. I think this is where my bias may come out, because I don't have strong evidence for what the choice that I made here. My inclination was to push the case numbers up by reducing the mortality rate until the turnover points were kind of in the region of 1 million people, rather than say 100,000 people, because I just can't see a reason why at the end of February there would, in any of the countries, there would have been something that stopped the disease spreading when there were only tens of thousands of people infected. So maybe there was, and I've missed it, but friends and colleagues in Germany have said that there was maybe, I suspect, maybe not quite to the same extent as in the UK, but that people were crowding into supermarkets and there wasn't mask wearing and things like that. Someone who wears a mask said, I was the only person in the supermarket wearing a mask. And that was actually after these dates. So, so I don't see a reason for what I've chosen to do here as being wrong. And so what we've got is a family of curves. We've got Italy and the UK, Italy and the UK as before, but I've actually pushed up the case rate in Germany and Sweden to bracket the UK. So Germany having more cases but lower mortality than the UK, and Sweden being just below. And you know, don't if you said, oh, you must bring this down a factor of 3, I wouldn't hesitate really to do so. It's just I had to put the curves on somewhere, and it's very uncertain. So what mortality numbers did I end up with for Germany and Sweden? I took 1 in 3,000. Okay, so that's 4 or 5 times lower than in the UK. And, you know, I'm not uncomfortable with that because I don't see why the gap should be quite that big. I think it should be lower mortality in Germany and Sweden, but I don't think it should be that much lower. So I remain doubtful, but the same, as I said before, that when it comes to fitting models to these, factor of 2 in these numbers makes a few days difference in the progression of the disease. So in the end, even though the curves end up in places that I'm not entirely comfortable with, even though it fits my bias, we don't really lose much from that, provided people are aware. So some of the things I had in mind were the Heinsberg study in Germany, where antibody testing, I forget which day it was, a week or 2 ago, gave 10 to 15% exposure. I think 15% with the Heinsberg study, and other reports have been more like 10%. But these are in small samples.
You say exposure, you mean estimates of the number of people in the population who have successfully been infected by the virus?
That's right. So they've mounted an antibody response, and I don't know, I don't remember whether these were, so when you mount an antibody response, the first type of antibody that your body produces is called immunoglobulin M, IgM. But it disappears or it decreases after a matter of weeks. And there's another one which comes along, which is IgG, which stays around for quite a long time. I don't know how long. Depends on the person and the virus and many other things. And most of the high quality antibody testing has required a positive in both of those. And so it has to be pretty much an infection that's reached a particular period. So it's a couple of weeks after the test, a couple of weeks after the point of infection or so, and not months after the point of infection, because at least the numbers I looked at for thresholds and so forth, the test becomes quite insensitive after a month or so. Now, I don't remember exactly which tests were used for which set of data here, but broadly speaking, that's the inferred possibly lower limit. So a number of people who were exposed, got the infection, expressed antibodies, and were found by the test. I think there wasn't expected to be a large false positive result in these tests. I don't think they would have found antibodies or thought they found antibodies in very many people who had not been infected because of the dual-pronged antibody approach.
And when did they do this this test?
I don't remember the exact date. I read about it coming on for a week ago. The one that gives the 15%. So I think it was just under 2 weeks ago data, but I don't. That's not clear in my head. And so, Germany's 80 million people. Now, this was a region, and it might have been a region somewhat higher infection rate than other regions. But it does point to, many, many millions of people having been expressed antibodies to the virus. Unless they were, unless it was a small sample, so they may have missed, they may have looked in places where the virus happened to have spread effectively. And I may have drawn this line a bit high. It's trending towards 10 million infections by the current date. So under 10 million a couple of weeks ago, a few million a couple of weeks ago. Maybe that's an upper limit. And I just, for no good reason, said that the mortality rate in Sweden is the same as the mortality rate in Germany, because I had to pick a number and I had no idea what it should be. But the curve looked too similar, so I thought, let's just use the same explanation for the two curves. But as you say, we won't know, because the Sweden numbers are actually quite small, and the turnover hasn't really happened fully yet. So those are the inferred case rates, and then I thought I haven't said much about the US, but I'll come back to that if I may. For those who can see the graphs, I only put the 3 countries and the 3 models on this, because otherwise it gets very crowded, and it's still a bit crowded. So we've got sort of red and magenta, green and cyan, and blue and black. So if we work from Sweden down, the model for Sweden is the same model as the model for Italy and the UK, same gradient, same rate of spread, and just a different start date, but only a slightly different start date, because of an exponential. A few days later means a dramatic decrease in the number of cases, and because we've taken a lower mortality rate, So I thought that was quite interesting because it's, I think, a not implausible start date. You could argue it's a little bit early and mortality should be higher, start date a little bit later. That's fine. It's not such a nice fit, but that's because we're boosting up very small numbers of deaths by a bigger factor, so the random statistics play a role. But I would say it's a fair fit, straight line up until, again, a few 100,000 cases. Okay, so qualitatively not that different from Italy or the UK. And then Germany is just paralleling that. Maybe the turnover is more like 1 million cases. Again, maybe that curve's a little high compared to what it should be. Maybe the start date's a little early compared to what it should be. But, you know, probably by days, not by more than that. And before I go on to the US, are there any points about those two that struck you? I was struck by the...
Sorry, Nico.
I was just going to say, I was struck by the fact that I didn't have to change the gradient.
Yeah, I was going to say that it's remarkable that you have this real kind of uniformity across countries in that explosive initial growth, and the inflection point coming. It'd be interesting to know how that number scales, you know. So for Germany it looks like a couple of million, for Sweden it looks like a few 100,000. Is that purely population, or is there must be some density, population density thing in there?
Yeah, and you know, I think that's the sort of thing that unfortunately this approach won't answer until later on, until it's done with much more sophistication, because factors of 2, you're starting to get close to worrying about factors of 2 there to do a comparison, and that's pushing it a bit, I think.
But no, it is remarkable and encouraging, actually.
Mm-hmm. Okay, and then we come to the US, and actually, because this is a...
Can I just say, sorry, going back to my thought about it being encouraging, I think the real worry is that this exponential growth will keep going into, I mean, obviously, each death is a tragedy, and I'm not trying to minimize the people that have succumbed to this. It's absolutely dreadful. But, you know, you get into apocalyptic numbers pretty quickly if that curve doesn't start rolling off.
Yeah, so this goes to the end of March, and we've got all these countries are hundreds of millions.
Yeah, dreadful. You know, if
you know, and multiply that by 1,000, and you know, it's the sort of models that the I didn't read the Ferguson Group, the Imperial College Group paper in great detail because I was too busy at that point to do it justice. But they were, you know, predicting like 500,000 type deaths and that sort of thing, and that's what you get if you take the exponential growth through into early April.
And then, of course, you come back to the question of what fraction of those would be excess, and I mean excess in relation to the ultimate eventual spread through most of the population anyway, and the deaths that come from that compared to deaths from overwhelmed healthcare.
That's true. Can we come back to that just in a minute? And then if I just finish off this little thing about the US, because the US, the differences were, so the startup's very strange. The sudden steep rise of from 1 patient to 10 patients in a day or two. But that may be something to do with death recording or the diagnosis becoming available on a chart or something like that. And then afterwards, on this particular slightly compressed scale, the curve doesn't actually look as odd as it did before. It's still a different shape from the others, but it doesn't deviate very far from an exponential line, but a much less steep exponential line. So it's taking a couple of days extra to double compared to the European countries, and that may be just geographical. Even though New York is dominating, maybe without New York, it would be even more gradual rise. And the turnover, and again, don't worry too much about the exact height and time on this curve, but the turnover that seems to be just starting now is happening at a not dissimilar fraction of the population to that in Germany. Germany's about, well, US is about 4 and a bit times larger than Germany, and there's, you know, convincing that it could be a per population effect on the turnover, which is interesting. But certainly there could be something interesting to see early on in the US curve, but there's not enough information for me to make anything of that. So I think those are all the comments that I came up with on the modeling. And then I was interested to see Werner Wheelock on Twitter. So Werner's views on Twitter yesterday had dug out, not sure whether it's Public Health England or NHS England or what, there's no credit on the image, but it's deaths in England, Wales, all respiratory diseases, 2010 to 2020, up till week 13, last week of 2020. And so normally there are, this must be, it's quite high, it must be, even seems quite high for daily numbers, but it must be daily numbers, thousands of deaths. Or is it weekly numbers? I'm not sure. But anyway, it shows a whole bunch of curves for...
sorry to interrupt, but you get 1,600 deaths a day normally, approximately.
Yeah, so this must be per week.
Yeah.
Yeah, this must be per week, and it's kind of a smoothed over curve, so it's calculated per day, but plotted, you know, with some sort of running thing per week. And so it shows the 52 weeks, 53 weeks in every year. And it shows 1,000, 2,000, 3,000, 4,000 deaths per week. And this is respiratory diseases. Okay. Which is a declining fraction of total diseases over time because, you know, things like reclassifying dementia as a cause of death and so forth, which has taken a lot of deaths that might have been previously classed as respiratory in the past, strangely enough. So it shows as an average for the early years of the last decade, and then there's 2015, which is a huge spike at the beginning of January with many hundreds of people dying every day from respiratory diseases. That's the biggest spike. 2016, much flatter. 2017, another huge spike, and there tend to be ripples that go on. And so what about the first little bit of 2020? Well, there was a spike, maybe a flu spike right at the beginning in the second week of January. And since then, up until tantalizingly close to the big rise in COVID deaths, just overlapping with a death rate of about 600 deaths per week due to COVID. The curve is remains below most of the other curves and is just coming up. Probably over this next few weeks, it will show a small excess, given the rates are, you know, we've seen the death rates turning over and about to decline. So I think that could be quite interesting, because it may be that the statistics end up being not terribly unlike seasonal flu or cold. Maybe with slightly higher numbers, certainly this first round of the infection. I think you wouldn't be surprised if the numbers are high, because immunity is as low as it will ever be. You know, it may be that there's no immunity next year, but it may be there's some. If it comes back in a year's time, it can't be worse than now, I think, unless some other horrible mutation happens. But that seemed to be unlucky. So I think it'll be very interesting to see in 2 or 3 weeks how these numbers look, and that would be quite a good indication of the prospects for the future.
Yes, absolutely. I hope Werner Wheelock keeps that up to date.
Yeah. So I think I'll stop sharing the screen.
Sure.
At this point, yeah. And
Yeah.
excuse me, I need to cough, so I'm going to mute.
Okay.
Instead, I've still had this slightly annoying lung thing and occasional coughs the past few weeks for whatever reason.
There's one main thing that I want to talk quickly about at the end, is that, you know, your main interest in nutrition and health science is in our mitochondria, which are the little power stations in our cells. And can you say briefly, you know, why they interest you so much then about COVID-19 and what we know about its effects on mitochondria, if anything, and also, you know, what could reasonably be done to shore that up in the short, medium, or long term?
Okay, that's a really good question, Ali. So interest in mitochondria because, well, they're the neglected, our slaves. I come to think of them as our slaves. By our, I mean every multicellular creature recruited the mitochondrion in as an energy generator and stripped it of all its rights down to nothing. In fact, took most of its genes away. And so the mitochondrion and functionally they've not evolved very much over a billion years. But even if genetically they've evolved a bit, they still do most of the same functions as in yeast or whatever in humans. And basically, as you said, they produce the energy that runs the metabolism to a large extent. And I think what struck me when I was trying to work out why I had been ill 10 years ago was that it was clearly down to not looking after my mitochondria, because, you know, even your slave workers, you've got to feed them if you want to get any work out of them, and you've got to not feed them something that's going to make them ill. And the thing that's going to make them ill is, well, in the short term, sugar's not good. But on the long term, omega-6 fatty acids in excess is pretty much mitochondrial poison for reasons that are laid out in extensive detail in the Hyperlipid blog, Peter's blog, as you could spend, in fact, I've done it, you could spend a month or so understanding that in full detail. But essentially, if you saturate your body, as much of humanity, and especially the West and more recently the East has been doing in the last decades and even century with linoleic acid and from seed oils primarily, then you really do change the energy generating process and the sort of resilience of the mitochondria against any attack. And that includes viral processes, and not so much that the mitochondria directly affect, well, the effect is, if you imagine you've got immune cells and they're trying to do something urgent in response to a virus, then you want them to have an unlimited energy supply. You don't want them to have sick mitochondria pumping out as much energy as a wind farm today when there's no wind. You want your mitochondria to be able to help your cells to fight, and you want all the antioxidant systems that are associated with mitochondria to be working so that your immune cells can attack the virus, and the cells that are doing that don't die themselves. So there's a whole range of different lines of thought. And to be fair, it's not necessarily practical or possible to say, oh, COVID does this to mitochondria and therefore this next thing happens, okay? But the approach that I took was to figure out, and I had two motivations for this. One was to understand the symptoms that I'd had, if it was COVID or wasn't, and to think of whether there were explanations that weren't being picked up or weren't being discussed openly, because the symptoms I had were kind of weird, breathlessness and so forth, and tiredness and other things that it just seemed a bit odd compared to the severity of the standard viral symptoms before that. So I thought maybe something to look for there. And then I was just kind of curious whether there's just been a pronounced association between people with some metabolic illness or poor metabolic health and the danger of COVID. I've seen claims ranging from 90 to 99% roughly of people who succumb have got either identified or inferred metabolic disease. You've talked about that already with others. And so I was curious to see whether there was anything else going on that was particularly different about COVID, or whether that explanation, that you just want best metabolic health, which would be the first expectation that puts you in the best position for attacking any virus or almost any type of illness. So I looked around at a few different papers, mostly clearly very high quality ones, although I'll mention one that's a bit different from that because it's so interesting that I think it deserves a mention, even though it's maybe not of the highest quality. So the first thing is, and I think you've probably seen discussions of people about whether the approach to ventilation is the right one. So someone gets on a ventilator which pumps air, in particular oxygen, but air into their lungs. And I hadn't really thought about that. And I learned from a paper by Gattinoni and others, American Journal of Respiratory and Critical Care Medicine, COVID-19 does not lead to a typical acute respiratory distress syndrome. And this is a very serious paper. And what they identify is, so normally the ventilator pumps the air in, provides pressure, and that's because very often the lungs behave as if they're stiff, right? And so they've got a lot of lack of compliance, as a physicist would say. So you want the lung to be like a nice soggy balloon, so when you blow into it, it expands rather easily, not like a really stiff balloon. But you have to, get a pump out and pump the air in. And the interesting thing is this stiffness does not typically seem to be a feature of people with COVID. And some it is for some, but far from all patients. And so the ventilator doesn't need to be set to such a high pressure. And the other thing is that normally, I hadn't thought about this, but your heart pumps, the right hand half of the heart pumps blood to the lung. And the lung is this sort of really complicated network of blood vessels that eventually lead to capillaries beside the alveoli, where the oxygen exchange takes place. Oxygen comes in and carbon dioxide gets released into the air, into the lungs and into the air. And I hadn't thought about it, but if part of your lung's injured, there must be a system to stop the blood going to that bit and let it go to another bit. And that's a vasoconstriction process, so that where there's no oxygen, your blood vessels actually contract in that part of the lung and force the blood to other parts of the lung. And I had to read up a wee bit on this, but it seems that the effect of that, so in other words, you put blood through the lungs, but it doesn't get oxygenated. You can't really distinguish that very easily from, let's say the blood didn't go to the lungs at all. It just passed from one half of the heart, just missed out the lungs, and that's called a shunt. And so a shunt is a word used for a lack of oxygenation of the blood, even though the lungs are being filled with oxygen. So they look into that, and so this seems to be a really real thing, not for every patient, but for quite a substantial fraction of them, maybe of order half. And when they actually look at CT scans, and they do some measurements of the compliance and the shunting and so on, they actually can calculate, they can infer how much blood is being pumped through these bits of the lungs that are not working very well because of the disease. And it turns out these lungs are hyper-perfused. There's more blood going through them than you'd expect, not less. And that means that what it looks like is the the vasoconstriction part of the lung function has stopped. Now, whether that's due to direct action of the virus or due to all these chemical messenger cytokines just driving the system crazy is really hard to say. But I think in either explanation, you would want your metabolic health to be as good as possible, right? So it's not that it's the muscles that are not pumping your lungs, it's the actual lung function is degrading. And that's why there's been some, occasionally, I think, very, very poor results with ventilation. And also the conclusion of this paper is, after considering all of the above, all we can do ventilating these patients is buying time with minimum additional damage, the lowest possible pressure, and gentle ventilation. So, they're developing a strategy. So that was indirect evidence along the lines of metabolic health and avoiding a cytokine storm when your immune system goes completely crazy, producing all sorts of chemicals that then cause consequential damage, as well as ideally the healing that they're meant to. Now, why did I make that connection? So I double checked. I mean, I knew that this would be the case, but I double checked, and I found a nice paper by Roth and others in Respiratory Research 2014 about inflammatory cytokines and pulmonary hypertension. So another way of saying the shunt effect is high pressure imbalance in the lungs. The lungs don't let blood through. And the diseases associated with that are things like chronic obstructive pulmonary disease. And so we look at that, and the paper concludes, it's a really good paper, lots of detail, but it talks about all the cytokines, interleukin-6 and tumor necrosis factor alpha, and standard inflammatory chemicals that flood the body and are definitely elevated in a viral infection, whether it's COVID or not. And so it basically explains why all the people with dysregulated immune inflammatory response are more susceptible to the disease, so diabetics, chronic vascular disease, chronic kidney disease, all of those, or even just metabolic aging if you haven't looked after your body very well and its mitochondria are behaving as if they were those of an older person. And, that essentially, to a large extent at least, is driven by consumption of omega-6 seed oils over a period of years and decades in particular. So basically omega-6, pro-inflammatory, in combination with these cytokines, the immune system revs itself up really out of control, and you get just a vast amount of consequential damage, including very possibly this problem with the lungs not being able to vasoconstrict properly. So, so far, nothing out of the ordinary, just, some interesting information from the practice, and horrible information from the practice, but nothing that made me think that anything odd was happening. And then, subsequent to having felt that I had some problem with oxygenating my blood and for exercise and so on, I went searching for to see whether there was anything there, and there's one kind of high quality clue, and that's in a paper in the Lancet by Chen and others, epidemiological and clinical characteristics of 99 cases of 2019 novel coronavirus pneumonia in Wuhan, China, descriptive study. Again, very serious, and they've just collected 99 cases worth of data and done a little very basic statistical compilation of it, not really analysis. And the one thing that does stick out is that 50% of the patients have decreased hemoglobin. So the iron chemical in the blood that carries the oxygen around is decreased. I'm not sure if that's a surprising effect for a viral illness or not. I couldn't quite get to the bottom of that. It's not often discussed. All the other results that they found were quite normal for viral illnesses, high interleukin-6 in half patients, different properties of the blood, serum ferritin, which goes along with the inflammation, C-reactive protein, which goes along with inflammation. All of those are kind of there, but there was this one thing that low hemoglobin, and then I thought, oh, I wonder if my hemoglobin was low, and that's what was causing me to have to breathe more and have a higher heart rate, which I did for a while. Anyway, enough about me. I
I've
then found
noticed
this.
a higher heart rate over the last few weeks, markedly.
Yeah, so mine was 20 beats per minute higher, and blood pressure was slightly high, and it's slowly coming back. Well, pretty fast now, coming back to normal. So something weird happened. But you know, how often have I not checked my heart rate and thought about it just because I was getting out of breath going upstairs, things like that. Anyway, I found this, probably one of the most frustrating papers that I've ever read. And oh my goodness. It's the authors are Leo and Lee, and it's a preprint, it's not a paper as yet, and its title is Covid-19 attacks the 1-beta chain of hemoglobin and captures the porphyrin to inhibit human heme metabolism. And at first I thought, oh, that's very, very interesting. So the 1-beta chain, the hemoglobin is a kind of four-sided structure, four-branch structure, alpha, beta, gamma, delta, and each one's got an iron in it, and each one carries oxygen. And for some reason, the details of the molecule, basically how well hemoglobin picks up oxygen depends on how much oxygen it's already got. And so the four corners of the molecule are not exactly of equal status in some subtle way. Anyway, I started reading this paper because I thought it had some very interesting information in it, and its motivation is that they claim hemoglobin and neutrophil counts of most patients have decreased. Neutrophil, a type of white blood cell. And I thought, right, where are all the references for this? And well, they're not really there, which is slightly sad. I followed up all the references in the paper, and they're not, and it doesn't, apart from the Chen one that I already mentioned, it doesn't point anywhere, which is a bit disappointing. But anyway, there's a motivation. The materials and methods section of the paper is, you know, if it was a student report, they would get a high mark for it. I mean, you almost feel you could go and do what they did because it's so detailed and I think accurate. And I've spoken with a couple of people who think that, you know, it's not fictitious. It's kind of, they did real piece of work. I wish I could judge the results better. The results are tolerably well presented. You know, the language is quite clear, the statistics are reported and so forth. And the results basically, so the virus has got 3 proteins that it gets you to express that are of an obvious function, the sort of thing, that capsule type thing, and the spike for binding and whatever. But it's got some, and it's also got a whole other bunch of proteins that people, other 10-ish, that people don't really know what they do yet. Okay, they're just given a name. They're recognized as DNA. Well, it produces RNA that produces proteins, but these proteins that your body expresses when you've been infected, it's not quite clear what they all do. And so they're not given functional names yet. And basically they studied, I think in a very directed search, I think they went looking for results. And that's the bit that worries me, because I don't know how likely it would have been to find results had they just looked anywhere else, okay? But anyway, having understood that, they look for non-structural viral proteins whose function is not immediately obvious that can interact with hemoglobin. And they do it in 2 different ways. They look at human proteins that normally interact with hemoglobin and look for bits on the protein that match. The function looks as if it might match. And they also model the binding of viral proteins chemically with the hemoglobin molecule by calculating the binding energy. So they do all the electrostatics and a big computer does all the electrostatics and gives them the result. And they also then look for the binding with porphyrin, which is what you get when you take the iron out of the hemoglobin, and you get this other chemical. It tends to be quite nasty and floats around the body. So people who express this protein a lot get porphyria, which are severe skin, usually skin and other problems. They also give statistical, tests, and they give p-values that are 10 to the minus 300 and stuff like that. And just ridiculously, you know, in a sense, it's not chance that they got the result, that they're measuring a real effect. But the question is, we don't have any idea how many other real effects that they haven't measured. And so I can't evaluate that. And then it goes downhill, because the discussion and conclusion sessions are pretty much gibberish, frustratingly so, and they contain a whole pile of ideas that just seem to be unjustified by earlier content, or I can't understand the language enough to make the connection, which is quite possible. And also irrelevant ideas about the evolution of viruses at the beginning of life. And so I don't know what's happened to that, whether there's a germ of an idea that's just not been turned into a good paper, or whether it's pretty much nonsense. But I'm quite interested to know in the future when it's followed up, you know, more carefully, more completely. And it's one of these funny things that, again, maybe complete nonsense, but just at the end of the period of breathlessness I was out in the garden and got these muscle aches when I was after gardening, which is ridiculous. But in that, it was cloudy, and at this time of year here, there wouldn't be much UVB, or it was a few weeks ago. Now there is, but a few weeks ago there wouldn't be. And the next day I had this really horrible sort of urticaria, eczema thing on the back of my neck. That's odd. I used to have skin problems before, when I had the poor mitochondrial health some years ago. No, this was a bit different. I didn't really think much of it. It was incredibly itchy and a bit painful. And fortunately, after a day or two, I tried some steroid cream on a bit of it. I don't have much success with steroid cream. I tried a bit, didn't do anything. And quite powerful one. And what happened is the patch spread around my neck, and then the middle bit cleared up. And there's actually a photo I put on Twitter of my neck showing that, to see that was the last day of the inflammation. And I had no idea what that could be. But then I had a sudden, after reading this, I thought, it couldn't have been porphyrins, could it? Because they're activated by UVA. So if you have porphyria, you have to screen yourself against even blue light, but certainly UVA and UVB. So anyway, that was just a sort of random thought that crossed the mind, and indicates why I'm quite interested in finding that out. So that was that. You know, I don't know where that goes, and I don't think there's any evidence that the blood function is necessarily affected, but it might be. There might be something interesting there that the virus has learned to do. I looked at a few other topics like clotting. Does it give us a different method? Well, there's a paper that says that one of this particular features of COVID-19 is that patients requiring hospitalization has been an increase in D-dimers. Now, D-dimers are usually regarded as a measure of cardiovascular disease. They come off the lining of your blood vessels when fibrin chemicals break down, I think. And so they're an indication of severe cardiovascular damage, usually. These people tend to end up in this really horrible situation. 70% of them didn't survive and got disseminated intravascular coagulation, which is just a nightmare, I think, in an intensive care situation, because your body just the blood system falls apart and misbehaves. And the interesting thing is, if you look back, can the D-dimer effect, be connected to metabolic health? And the answer is yes, it can, rather directly. Patients with this kind of general pulmonary problems have elevated plasma levels of C-reactive protein and inflammatory markers, the ones we mentioned, including D-dimer, interleukin-6, TNF-alpha, and so on. And an experiment was done with mice by SFYRE and Matsakis in the Journal of Biomedical Science 2017. Crossroads to peripheral atherosclerosis, Western type diet, and skeletal muscle pathophysiology, emphasis on apolipoprotein E deficiency and peripheral arterial disease. And so they've drawn connections between metabolic health in mice, admittedly, but also a bit in humans, and the Western diet, so-called Western diet, which in mice, that basically means lard and corn or canola oil and casein and vitamins and things. So it's a bit of a starch. It's a very horrible diet even for a mouse, and that produced elevated standard mitochondrial symptoms, elevated reactive oxygen species in blood vessels and in plasma. But it also produced hypoxia because they saw effects where something was going on that was producing, this may be very much at the heart of atherosclerosis, that one of the things that goes wrong in cardiovascular disease is your arteries start growing all these extra little blood vessels inside their muscle. And that's where the clots form from. They grow up from the inside out. And basically, they found that there's an indicator called hypoxia inducible factor 1 alpha, HIF1 alpha, which is, as the name would say, occurs when you get hypoxia. Hypoxia has been caused in the arteries and the blood vessels, and then they were growing their own little capillaries to bring in more oxygen. So that's a very sensible thing, but that was tightly tied to the production of the D-dimers. And so it does seem that the blood dysregulation in advanced COVID is, certainly basically tied together with that. And then that made me think, well, what's the virus got to do? Why does the virus do this? And it turns out there's a very powerful reason, at least my limited virology knowledge indicates there's a very powerful reason. And that is because turns out that I think it's normal for RNA viruses that they come into your body, they can't do anything, and the simple story is they've got this binding sort of spike that meets up with one of the receptors in your cells, but it turns out that's oversimplified. And the virus can't bind, or at least can't bind very well at all, until your body has actually helped it along. And it turns out that to render the virus able to infect a cell, essentially that cell or one very nearby has to produce a protein cleaving chemical that kind of activates the virus, and then it binds to the cell. And maybe that's evolutionary, so that the virus is binding to the right types of cell, because it might bind to all different cells all over your body. And if it's not getting into your lungs, it's not going to spread, or your throat, it's not going to spread very much. So in any case, there's a paper structure, function, and antigenicity of the SARS-CoV-2 spike glycoprotein, walls and others in cell. So it's a really nice paper produced at very short notice. And it talks about an enzyme, a human enzyme called furin, F-U-R-I-N, which kind of lets the cells express it, activate the virus, and then the virus infects the cell, which seems like a really bad thing for the cell to do, but I'm afraid that's what happens. It turns out that one of the drivers of expression of this protein on the surface of cells is hypoxia inducible factor 1 alpha. So a virus that can induce hypoxia in your body can infect more cells more quickly. And I think that's probably a particular horrible aspect of this virus. I think it's normal to coronaviruses. I think all the coronaviruses do this same trick or a very similar trick. And there may be more than one process. There's another paper in Cell, I think it's the same edition, which talked about a different cleaving protein. But that was the one I followed up, and it did look quite respectfully written paper that was fully justified and explained that. So, you know, I think you can see a bit how the virus kind of adapts to the human metabolism. And just to say it again, that having a more robust metabolism, so you don't have on so many cells hypoxia being induced by poor metabolic health, gives you a bit of an advantage in the early stages at keeping the virus at bay. And I think, you know, the race against time in the first few days might actually say a lot about the course of the disease as it progresses. The very last comment that I thought I could make on this topic was there's some papers, reanalysis of SARS-CoV-2 infected host cell proteomics, etc., by Ortea and Bock, which is a preprint, which was looking, using computation, trying to figure out what all the, selecting down all the different changes in protein expression. So you take some cells, and it was a human adenocarcinoma cell line from the intestine that they infected, and then let the virus work for 24 hours, and then used a lot of very fancy analysis and computation to figure out what changes in expression of genes there had been in that 24 hours, so what the virus did, and what the virus made those cells do. And it turned out there weren't very many. I think the authors are, you know, in a cautious scientific way, quite surprised by the fact they only see 6 areas of metabolism that are affected very much at all. And if I mention 2 of those, well, you'll laugh or cry. I think cry is probably more appropriate. I'll just preface this, though, by talking about snake venom, not snake oil, snake venom. And I didn't know, or at least I'd forgotten, that snake venom works largely by activating a chemical or an enzyme that's in your body already. Actually 2 enzymes, or a set of enzymes, the phospholipases. So these are things that break down the lipid chemicals in the membranes of your cells. So we all know about this double layer membrane on our cells made out of phospholipids and phospholipases. There's a whole class of them, but particular ones called phospholipase E2 and another one that's related to that, expressed in a different place on the membrane. They break down the membrane. Sometimes you want to break down your cell membranes to replace, repair, add, whatever. And so what snake venom does is it encourages you to use that to break down your own cells, and that's why you get the destruction of tissue. Spider is the same. So it's this really horrible process where if you can get extra expression of these, you can really break down the cells and cause metabolic chaos, leakage of contents, and, you know, a virus spreading maybe, and whatever. So anyway, unfortunately, COVID. So the strong signal that we discussed first from this analysis of differentially expressed genes is linoleic acid metabolism, number 1, linked to arachidonic and acid metabolism, eicosanoids, so these inflammatory, pro-inflammatory chemicals. Therefore, it could play, very, very cautious statement, could play a role in the inflammatory response observed in stages 2 and 3 of the COVID-19 patients. So it looks like you get an infection and the virus tries to destroy your cells to be able to spread out. At least that's my naive picture of it. And the 2 proteins involved in this are the phospholipases, and both proteins have a clear increase at 24 hours after virus infection, and they suggest that be explored in more detail. So that's number 1, that does the seed oil, right? Number 2, another pair of upregulated proteins is hexokinase 1 and another one called hexokinase domain containing 1. And these are, to use the words proteins related to glucose use, homeostasis. So presumably, hexokinase has been previously associated with inflammatory response in autoimmune disorders. And upregulation could be linked to the propagation of inflammatory reaction and lung injury that's observed in advanced stages of COVID patients. And I think, given the link there with glucose use, that does point perhaps to the danger of being insulin resistance and high glucose availability, because the virus is wanting your cells to burn lots of glucose, and so if they're biased in that direction because of poor metabolic health, then you're not setting yourself up for a good future. So the summary would be, I think, and it is my bias that, that I've been well educated by Peter Hyperlipid and Tucker Goodrich. I expect to find that poor metabolic health is really a disaster in situations like this. And with that one little maybe different thing about the hemoglobin, it's all just 100% consistent with that. And if even a small fraction of the population gets to find this out in the longer term and decides to change their metabolic health, then in the long term that'll maybe win back some of the damage that's sadly going on.
Yeah, well, it's a sobering thought to end on. But we've covered so much, and I think what I'd probably like to do is revisit, the data in, I don't know, a month or so, and do another series of COVID-19 shows. I feel like we might be reaching, close to saturation on the amount we can take from the data up to this point, and thoughts on speculations on it. And then I guess maybe in a month or so, we'll start to really have a much clearer picture of how it went.
Yeah.
So,
well, sadly, I think I'm now addicted to the odometer data, so I probably will find myself, I wasn't going to do it yesterday, but I did. I just snuck in that extra last day of data, and I think I'm probably condemned now for the next few weeks at least to
how your model plays out.
Yeah.
Mm-hmm. Yeah, well, I'll be keeping an eye on it, and that's probably the best place to see your thoughts on it, isn't it? Is on your Twitter.
Yeah, for sure. I don't really have another outlet other than your podcast for this. So I'll certainly there's a couple of things I've held back until doing this, which I might let leak out over the next few days. But yeah, I'll keep in touch that way for sure.
Brilliant, and I'll put the link to your Twitter in the show notes. Well, thanks again, Ken. Thanks for joining us.
Well, thank you, Ali. It's been good to talk, and good luck with all your endeavours that are underway.
Thank you.